This is page 5 of trig. Remember how last time we were talking about sine rule, law of sines? Now we're going to talk about cosine rule, and since we are talking about cosine rule now, let's talk about when you use cosine rule, when you use sine rule. First of all, sine rule is a lot easier to use than cosine rule. So if you can use either one, make sure you use sine rule. So instead of like inventing a whole bunch of rules like textbooks usually do, I have one rule to figure out whether or not you should use sine rule or cosine rule, and that is see if you can use sine rule. If you can use sine rule, use sine rule. If you can't use sine rule, then use cosine rule if you have to. Okay? If you are going to use cosine rule, notice that there's two different versions of cosine rule. There's the left one, which has c squared on the left side, and there's the right one where cosine capital C is on the left side. When you want to know an angle, then you use the right one because the angle is on the left. When you want to know a side, then you want to use the left one because there is a side on the left side. In both cases, they can be manipulated so that they become the other, but it's easier if you use the one that has the unknown side on the left, and then the unknown angle, use the one on the right. Okay. When you label triangles, make sure that you follow the rule that, okay, if I say capital A, capital B, capital C are the corners, the sides are going to be labeled with the same letter across. So this would be small c, right? And this would be small a because it's across from big A, and this would be small b because it's across from big B. Make sure you never violate that rule, otherwise you're going to get the wrong answer. Okay, so let's do number one, and the first thing we're going to do is we're going to check to see if we use sine rule or cosine rule after we draw the picture to see which is the appropriate one to use. So for part A, I'm going to draw first a triangle, and it's going to have vertices A, B, and C, and the sides are going to be across from big A, I'm going to put 12, across from big B, I'm going to put 6.5, and across from big C, I'm going to put 7. So we know 3 sides, and we would like to know, it says to find all the sides and angles. We have all the sides. Instead of finding all the angles, I'm just going to find the first angle, and then I'm going to explain how to do the other 2 angles, because only the first angles are going to require law of cosines, which is our topic today. So how do you do that? What you're going to do is you're going to check to see if you know any side angle pairs. What do I mean by side angle pair? This would be a side angle pair, this would be a side angle pair, and this would be a side angle pair because they're opposite from each other. Okay, so in this case, do we know any angles? No, we don't. Do we want to know any angles? Let's say that we're trying to find angle A. So we want to know this angle, and we don't know any other angles. So looking at this one here, we have this side angle pair, which is relevant, and we have no other side angle pairs. If you only have one side angle pair that is relevant to your problem, then you know you can't do sine rule, so that automatically means you're going to use cosine rule. So in this case, since it failed the test to find 2 side angle pairs, we know that we should use law of cosines. Okay, so let's do law of cosines. So law of cosines, we're going to use either the left one or the right one. In this particular case, we want to know an angle, so we're going to use the left one. Okay, so it's cosine C equals a squared plus b squared minus c squared divided by 2ab. In this case, unfortunately, my angle is called A and not C. So what I'm going to do is I'm going to relabel my triangle so that all the sides and angles follow this convention where the angle is called C. So instead of red A, I'm going to call it blue C. And then instead of red C, I'm going to call that blue A. And then B can stay B. Okay, so I'm going to use the blue labels instead of the red labels because I want to match the format here, which is that the relevant angle, which is the only angle that I want to know or I know, is going to be matching this equation which has C in it. So that means that this would be little a blue A, little blue A, and this would be little blue B, and this will be little blue C. Okay, now I'm going to fill in everything into the formula. So on the left, I'm going to have cosine C. So that would be, in this case, cosine C. And then on the right side, I'm going to have A squared plus B squared. So that would be 7 squared plus 6.5 squared minus C squared, which would be 12 squared. And on the bottom, I would just have 2AB, which will be 2 times 7 times 6.5. So I'm going to put that in my calculator, and then I'm going to eventually figure out what C is. When you put this in your calculator, I recommend using the vertical fraction, because then you don't have to worry about putting parentheses around the top and around the bottom. If you don't put parentheses and if you don't use vertical fraction, you're going to get the wrong answer. Okay, so how do we find vertical fraction? We press Math, and then we go to Number, and then we go to the bottom by pressing up, n/d. We're going to hit that, and then we're going to type in the top. And we don't even need to put any parentheses, because when you do a vertical fraction, it automatically assumes there's parentheses on top and parentheses on bottom. Minus 12 squared. And then in the bottom, I'm just going to have 2 times 7 times 6.5. And then I hit enter. And I get negative 0.580. And in this case, I'm going to write this down real quick. So I have cosine C equals negative 0.57 or 580. Okay, and then if I want to find out what C is, remember I need to undo cosine, which I do by putting inverse cosine on both sides, and then these two cancel out, and I'm left with C equals inverse cosine of negative 0.580. So let's do that. We can do inverse cosine, which you do by doing second cosine, and then I grab negative 0.580, and my answer is 125 degrees. Okay, how would I find the other two angles? Well, the second angle, let's see, once we know that this is 125 degrees, we know that blue C is 125 degrees. Let's say that we want to find blue A now. If we want to find blue A, then that means that we know this pair, and we know or would like to know this pair. So we have two pairs. That means we can use law of sines, just like on the previous page. Okay? And once we find this angle here, once we find the answer to this angle here, then notice that we have two of the three angles. If we have two of the three angles, how do we find the third angle? We can find the third angle by doing 180 degrees minus the first two angles. So do you see, only the first angle you need to use law of cosines. The second angle you'll be able to use law of sines, and the third angle you can just use 180 degrees minus the two angles. So I'm not going to do the other two angles, okay? Let's do letter B now. So letter B is basically the same problem. It's just got three other dimensions that are in millimeters. So I'm going to set this up. We won't do it all the way over because, you know, this is basically the same problem again. It's got three sides just like the other one. So I'm going to label it A, B, C. And so this will be little a, this will be little b, and this will be little c. So A is 11, and B is 14, and C is 18. And what I want to know is I want to know all the angles, but let's say, okay, let's find angle A first, okay? Of course, when we do the test to see if we have two side angle pairs, we only have one, so we can't use law of sines, we have to use law of cosines. When we do law of sines, law of cosines, remember that the left side, we want to use this one because we have an unknown angle, so we want to use the right one here, right? Now the left side says cosine C. Our relevant angle is A, not C. So what we're going to have to do is we're going to have to relabel everything so that this is blue C, and then this is blue A, and this can remain B. And by relabeling, that allows us to use the formula as is, right? And so this will be blue A. Okay, so I relabeled everything with the blue letters. Make sure you follow the blue letters. I'm going to fill in all my data. So cosine C equals A squared, which is 18 squared, plus B squared, which is 14 squared, minus C squared, which is, oh, I'm sorry. Yeah, blue C is 11 squared. Okay. Yeah, I have to keep my eye on blue, right? And then on the bottom, I'm going to have 2AB, which is 2 times blue A is 18 times blue B is 14. Okay, and then you would just put that in the calculator, and then you would do inverse cosine like what we did here, and then you would find the angle C. And then for the second angle, you could use law of sines, and on the third angle, you would use 180 minus the first two, just like we did in part A. Okay? All right. Let's do the last one here, which is we know a side and two angles. Okay, so let's see. We're just going to use the exact same rule that we used before, so don't worry. I'm going to label A, B, C in blue. And then little a, little c, and little b. And so angle A, we know it's 25 degrees. Angle B, we know it's 83 degrees. And side C is 22. Side C is 22. Okay. So do we, like whenever you have a situation where you know two of the angles, think about how you would find the third angle without any difficult trig. Remember, all these three angles add up to 180. So we can find this third angle by doing 180 minus 83 minus 25, right? So it would be 180 minus 83 minus 25. And that gives me 72. So I can write 72 here. I know all three angles. Now that I have filled in all the angles, which I can easily find, I'm going to see, okay, how many side angle pairs do I have? Just one. But we do want to find out side A and side B, right? So if we want to know side A, then we do consider this to be a valid pair. So if we have two pairs, that means we can use law of sines. So this is a problem actually where we can use law of sines. How would you set it up? You would set it up with sine A and little a, and you would have sine C and sine C and little c. Now, sometimes sine is on top, sometimes the sides are on top. How do I know that I'm supposed to put the sides on top? Because, remember from yesterday, the unknown side, you want that to be on top. So little a is unknown, so you want to put that on top, which means the signs go on the bottom. Okay? So basically, letter C could be solved using law of sines. Okay? Let's see, 2a. Find the side y. Okay, first of all, let's see if this is a law of sines problem or a law of cosines problem. If we want to know y, this is definitely relevant. Other than that, we have these two sides and we have this angle. Let's see, do we have two side angle pairs? No, we just have one. So that means that this is definitely the law of cosines problem. And we want to know a side, so that means we're going to use this equation here with the c squared on the left, okay? So first we're going to write that down. C squared equals a squared plus b squared minus 2ab cosine big C. And let's label all the sides. So big C is going to be the one angle that we have. This is going to be blue C. And then if this is blue C, then y is going to be little blue C. And then the other two sides are going to be A and B. So that means this would be big A and this would be big B because they're opposite, right? Okay, so now let's fill in everything. So C squared is unknown. We can actually call it y squared because that's what they call it. A squared, little a squared is going to be 12 squared. little b squared is going to be 7 squared, and then minus 12, 2 times 12 times 7 times the cosine of c. It's going to be cosine of 86.5 degrees. Okay? Now I'm going to simplify the right side, and eventually we're going to have to take the square root of it, but first we're just going to simplify it. So we're just going to find what value it is. 12 squared plus 7 squared minus 2 times 12 times 7 times cosine of 86.5 equals 182.7 rounded to 183. And then I'm going to take a square root of both sides because my final answer needs to be y equals something. So I take the square root of both sides. So the answer is 13.5. Okay? All right. Part B, find side x. Or it's actually angle x. We want to find angle x and we know all the sides. Can we use law of sines? Let's do the test. There is one side angle pair. So no, we can't use law of sines because we need two side angle pairs in order to use law of sines. So we're going to use law of cosines again. The question is, should we use this one with little c on the left or the one with big C on the left, big C being an angle? And our unknown is an angle, so we're going to use the big C one. So the one we're going to use is cosine big C equals, and then a squared plus b squared minus c squared divided by 2ab. Is that right? Yeah, that's right. Okay, so that's our equation. And unfortunately, our triangle is labeled wrongly with ABC in the wrong place. How do I know that? Because the only relevant angle here, the angle that we want to know, or the one that we have, but we only have one that we want to know, and there's none that we actually have, we need to call this big C. So I'll call this big blue C, which means that 10 is little blue c. And that means that this big C cannot be big C because we already used big C. I'm going to call this one big B. And then it means this is small b because it's opposite. And A can remain as is, okay? So I've labeled all the sides with my new blue letters, and I'm going to respect those blue letters only. So angle C is actually x, so I'm going to put cosine of x equals a squared plus b squared. It's going to be 15 squared plus 8 squared minus c squared, which is 10 squared, divided by 2 times 15 times 8. Okay, now let's simplify the left side with the calculator. Remember, let's use vertical fraction so that we don't have to put parentheses around the top and the bottom. So this will be 15 squared plus 8 squared, which is 64, minus 10 squared, which is 100. And then in the bottom, we're going to put 2 times 15 times 8, which is actually 30 times 8. Just saving time by doing some of the calculations in my head. 63 divided by 80. Let me write that down. And now what I want to do is I want to get rid of the cosine so I can get x by itself. So I put inverse cosine on both sides, and these cancel each other out and leave just x. So now I'm left with x equals inverse cosine of 63 over 80, which is equal to inverse cosine is equal to 38.0. So the angle is 38.0 degrees. Okay, so that was this one here. Let's do this one. In triangle ABC, CB is 120, AB is 115, and angle B is 110 degrees. Find the length of side AC. This is only difficult because we need to draw the whole triangle. Let's draw the whole triangle. I didn't mean to make that look like a right triangle. Let's erase one side so that it doesn't look so much like a right triangle. Okay, A, B, C. CB is 120. AB is 115. angle B is 110. Find the length of side AC. So we'll call this, well, we won't call it anything for now. We'll just put a question mark. Now, I'm going to mark everything in blue so that we can use the right formula. Now, first thing is we're going to see if we can use law of sines or law of cosines. So in this case, this is a valid side angle pair. We want to know side AC, and we do know that angle. There's no other angle, so that's it. We don't have any other side angle pairs, so we can't use law of sines, which requires two side angle pairs. So now what I'm going to do is I'm going to use law of cosines, and since the side that we want to know is a side and not an angle, then I'm going to use this equation here that has a side on the left. So I'm going to write that down first. I'm going to put c squared equals a squared plus b squared minus 2ab cosine c, just copying what's up there. And now I'm going to label all the corners with blue letters so that it matches this here. And remember, the relevant angle is big C, so I'm going to label this angle big C, and that means this opposite side is little c, and that means this can't be red C anymore, or it can't be C anymore. It has to be blue B, and this will be little b. Okay, and this could still be A. There's no problem with that being A. Now let's fill everything in. So little c squared we don't know, so it continues to be little c squared unknown. And then we put 120 squared for A, and then we put 115 squared for B, and then we do minus 2 times 120 times 115 times cosine of big C, which is cosine of 110. Now I can simplify all this by putting in the calculator. So 120 squared plus 115 squared plus minus 2 times 120 times 150, 2 times 120 times 150, 115, sorry, not 150, 115, times cosine 110. Enter. The answer is 37,064. 37,064. Now that's a c squared. I would like to know what c is, so I'm going to square root both sides. So that would be square root of that big number. And the answer is 193. C equals 193. And that is the answer for the length of side red AC. Okay, and that's what they wanted to know. Last one. The straight line distance between two cities ABC is 223. AB is 223. The straight line distance between cities AC is 152. Oh, so actually this is just a fancy way of drawing the same ABC triangle we already drew many times. And last of all, this would be C, right? The straight line distance between B and C is 285. Find the angles between each of the three cities. Remember, the first angle we're going to find, let's see, we're going to find angle A. And since if we do our test to see if we can use law of sines, there's only one side angle pair that is relevant. We cannot use law of sines, so we're going to have to use law of cosines. We're looking for an unknown angle, so we're going to use the law of cosines that has cosine C on the left. Okay, so I'm going to write that out here. Cosine big C equals a squared plus b squared minus c squared divided by 2ab. Unfortunately, the relevant angle is called capital A instead of called capital B. So now we're going to need to change all of our corners so that it respects this naming convention. So big C is going to be the relevant angle. This is our relevant angle because this is the one we want to know. So let's call that C. If we call that C, this C has to become A, and then B can just remain B. So this will be little b, this will be little c because it's across, this will be little a because it's across. Now let's fill everything in. So cosine of unknown, so we'll call this angle big C, is equal to blue little a, which is 223 squared, minus little blue b, which is 152 squared, minus c squared, which is 285 squared, divided by 2 times 223 times 152. So let's simplify the right side with using vertical fraction because we don't want to put parentheses in around the top and the bottom. It's kind of easy to forget and then it'll lead to a mistake. 223 squared. I'm sorry, that should be plus. This should be plus, right? 152 squared plus 152 squared minus 285 squared. 285 squared. On the bottom, I'm going to have 2 times 223 times 152. Okay, and so that gave me a negative number, that's a fraction, and now I'm going to get rid of the cosine by doing inverse cosine. Inverse cosine here and inverse cosine on the simplified result of this, which is negative 1049 divided by 8474. So that we're going to do inverse cosine on this, right? Negative 1049 divided by 8474. Let's do inverse cosine on that. Second inverse cosine. Grab the fraction. The answer is 97.1 degrees. So blue C is 97.1 degrees, and that is this angle A that we wanted to know. Now that we know red A, how would we find blue B or blue A? We would find these by using law of sines to find the second one, right? Because now that we know that this angle is 97.1 degrees, look, and then if we wanted to know angle B, for example, that means that two of these angle side pairs are relevant. These two sides are relevant, right? We know 3 of the elements, and we just don't know 1 of the elements. So now we can go ahead and use law of sines. And once we find angle B, if we know blue angle C and we know blue angle B, that means we know 2 of the 3 angles, and we can find the third angle by doing 180 minus the 2 angles that we know. So you only need to do a law of cosines to find the first one. The other 2 you can use law of sines, and then you could use 180 degrees minus the 2 angles you know. So that's it for this video.